Dear students, so I am going to solve one of the important question. This question is asked many times in the examination. Discuss the continuity of the function f defined by f of x is equals to. The function is x plus 2 if x is less than or equals to 1 and x minus 2 if x is greater than 1. Here the function is in pieces, not in a whole. So that we use the formula, that is limit as x tends to c minus is equals to limit as x tends to c plus is equals to f of c. When the function is given in a pieces like this, more than one function, so we use the formula this to check whether function is continuous or discontinuous. If the function is not in pieces, just we have to use the formula, that is x tends to c, f of x is equals to f of c. This is only for when the function is given in only as a whole, but the function is given as pieces, we use the formula this is nothing but LHL, left hand limit. This is nothing but RHL, right hand limit, and f of c. So the function obeys or satisfies the condition LHL is equals to RHL is equals to f of c. Then only we can say that the function is continuous. Otherwise, the function is discontinuous. If LHL is not equals to RHL, the function is discontinuous, and it is not necessary to check f of c when LHL is not equals to RHL. If LHL is equals to RHL, then you have to move forward to check f of c. If LHL is equals to RHL, but LHL is equals to RHL is not equals to f of c, and that occasion also the function is not continuous. So that now we have to check the continuity of the function. First of all, limit as x tends to c minus, that is f of x. This is LHL. LHL is equals to limit as x tends to c minus. C minus indicates this is the LHL. So here limit as x tends to c is nothing but there is a 1. That is the limit. That is a 1 minus. When x is less than 1, on that situation the function is x plus 2. So that is f of x is x plus 2. Now taking limit, here put the value of x equals to 1 here. This is 1 plus 1 is equals to 2. So LHL is 2. Similarly for RHL. So RHL is equals to limit as x tends to c plus f of x. Limit as x tends to 1 plus, because limit is 1. So and when x is greater than 1, the function is, that is x minus 2. X minus 2. So taking the limit, that is 1 minus 2. This is equals to minus 1. This is RHL. So here LHL is not equals to RHL. LHL is not equals to RHL because what is the value of LHL? Is 2. And the value of RHL is minus 1. Hence LHL is not equals to RHL. Therefore, it is not necessary to find f of c. So that we can easily say that the function is the function f. Therefore, the function f is discontinuous. That x is equals to 1. It means LHL is not equals to RHL means limit does not exist, means limits are not coincide. The function exists only if LHL is equals to RHL is equals to f of c. Otherwise, the function is not continuous. Dear students, welcome back to mathematics class. Here, now we are going to solve some examples. Here is the function defined by f of x is equals to modulus of x is a continuous function. They asked if the function defined by f of x is equals to modulus of x is continuous function. Okay. So here let us consider the function f of x is equals to modulus of x. Now we can write modulus of x as minus x if x is less than 0. The value of x is minus x when x is less than 0. and the value of x is positive when x is greater than equals to 0. So here we have two functions here. So that we have to check here the continuity of this function is by using the formula, that is limit as x tends to c minus is equals to limit as x tends to c plus is equals to f of c. If the function satisfied this condition, then the function is continuous. Otherwise, the function is discontinuous. Yes, let us check. Here c is 0. Now LHR. LHR is nothing but limit as x tends to 0 minus, because left hand limit is represented as limit as x tends to c minus. Means here c is nothing but 0. Hence limit, this is only for left hand limit. Hence limit as x tends to 0 minus. When 0 minus c is 0 minus, on that condition we consider the function which is x is less than 0. On that condition the function is minus x. Hence we in place of f of x, first generalization, x tends to c minus f of x. Limit as x tends to 0 minus, when the minus x is less than 0, the function is minus x. Take limit, put 0 in place of x, that is minus 0, that is 0. So LHR is equals to 0. Now similarly RHR. RHR is nothing but limit as x tends to c plus f of x. What is the function? If x is greater than equals to 0, that is x. The function is x. So that limit as x tends to 0 plus the function is x. Applying, taking a limit, limit 0 is a limit. Put the value of x is 0, that is 0. So this is RHR. Now check for f of 0. So here is equal symbol is here, that is x equals to 0. On that condition function is x. Therefore here f of x is equals to x. Therefore f of 0 is equals to 0. Now we have LHR is equals to RHR is equals to f of 0. So that function f is continuous function. Okay, now I will solve another example. Dear students, I continue the exercise 5.1, in which third one I already solved first and second. So examine the following functions for continuity. They given here some functions and they asked to check the continuity of all these functions. First one, that is f of x equals to x minus 5. To check the continuity of this function, f of x equals to x minus 5. So here you take here c is equals to a, means a belongs to R. This is the limit here. C is equals to a is the limit. It is nothing but belongs to the real number R, because the limits are not given here. Hence we have to take a as a limit, which is nothing but belongs to a real number, some real number. This is limit, c is limit, which value is a. Here a is nothing but this is taken from the real numbers. For our simplification, we take here. Now here the function is single only. Hence we use the formula limit as x tends to c, f of x is equals to f of c. Okay. Now limit as x tends to a, because in place of c here we have a. A is nothing but some real number. This is, what is f of x here? The function is x minus 5. X minus 5. So that taking limit, taking limit, put the value of x is equals to a then in this function, that is a minus 5. This is equals to a minus 5. Similarly, f of a is equals to f of a is equals to put where x is equals to a means it is f of x. In case of x, put a. So that is a minus 5. A minus 5. Therefore, limit as x tends to a, x minus 5 is equals to f of a is equals to a minus 5. Therefore, the function f is continuous. The function is continuous. Similarly, we have to check the continuity of the function. Second one, f of x is equals to 1 by x minus 5. Second one, here f of x is equals to 1 divided by x minus 5. The condition is x is not equals to 5 here. Here, if x is 5, then what happens? 1 by 0. So 1 by 0 is not defined. Hence, the condition is x is not equals to 5. So that here also we have to check limit as x tends to c equals to f of x is equals to f of c. So here take c is equals to a belongs to some real number. Then limit as x tends to a, f of x is here 1 by x minus 5. 1 by x minus 5. Taking limit, the function becomes 1 divided by a minus 5. Similarly, we have to check for f of a. F of a is nothing but in place of x, we have to put a, that is 1 by a minus 5. Observe these two, both are same. Hence, limit as x tends to a, 1 by x minus 5 is equals to f of a is equals to 1 divided by a minus 5. Therefore, f is continuous. Therefore, f is continuous. F is a continuous function. Now, similarly, third example. Third one. That is f of x is equals to x square minus 25 divided by x plus 5. See here, what happens if x is equals to, the function is not defined or indeterminate form when x is equals to 5. Therefore, we have to rewrite as f of x is equals to, this is in the form of x plus 5 into x minus 5. Because a plus b into a minus b is equals to a square minus b square divided by x plus 5. So here x plus 5 get cancelled. So that is the function becomes a polynomial function. F of x is equals to x minus 5. Again, we have checked for the continuity of this function. So the function is converted to in this form. In this form, we converted the function into a linear function. This is a linear function. Okay. So now for the continuity, we have to check for limit as x tends to c, f of x equals to f of c. Limit as x tends to a, because here a belongs to, x is equals to, c is equals to a, belongs to r again. That is, function is x minus 5. Taking limit, this is nothing but a minus 5. Similarly, f of a is equals to, that is a minus 5. Therefore, limit as x tends to a, x minus 5 is equals to f of a is equals to a minus 5. Therefore, f is continuous. F is a continuous function. Similarly, the fourth example. minus of x minus 5 if x is less than 5. So here, what happens if x equals to 5? 5 minus 5, 0. So it becomes, what happens if x is greater than 5 means 6. 6 minus 5, that is 1 plus 1. 7, 7 minus 5, 2. Like this. What happens if x is less than 5? That is less than 5 means 4. 4 minus 5, minus 1. So that for x is greater than 5, we get a positive x minus 5. For x is less than 5, we get a negative x minus 5. Hence, we have the two functions here. We have the two functions. So that we have to check here, limit as x tends to c minus equals to limit as x tends to c plus equals to f of c. If this function satisfies this condition, then we can say that the function is continuous at 5. So that now, for left hand limit, that is LHR, is equals to limit as x tends to 5 minus. The limit is c is nothing but 5 minus. 5 minus means left hand limit, means from moving from left to right. So that when x is less than 5, the function is minus of x minus 5. The function is 5. Taking limit, so put x equals to 5. This is nothing but minus 5, that is x is equals to 5, sorry, 5 minus 5, this is 0, this is equals to 0. Similarly, you have to check for right hand limit. RHS is equals to limit as x tends to 5 plus, that is on that condition, on that situation the function is x minus 5. X minus 5. Taking limit, this is 5 minus 5, also 0. This is RHS. So now f of 5. F of 5. So here the symbol is equals to existing in this function. The symbol is equals to exist in this function. Hence we consider for this f of x is equals to, okay, on that condition the function is x minus 5. Therefore f of x is equals to x minus 5. So that f of 5 is equals to 5 minus 5. This is also 0. Therefore limit as x tends to 5 minus equals to limit as x tends to 5 plus equals to f of 5 or equals to 0. So that the function satisfied the condition limit as x tends to c minus equals to limit as x tends to c plus equals to f of c. Therefore the function is continuous. Therefore f is continuous function.